And it's point-to-point connectivity. So the meter is talking directly over, directly from itself up to the utility station. The advantages of that is you're already using existing infrastructure. You do not have to roll out your own license spec setup or anything like that. You rely on the cell tower. You rely on AT&T or T-Mobile to do it for you, and you worry about them. You take that for what you will, I guess. You let them spend the money to roll out service and coverage into other areas. You don't have to worry about that. Your coverage cell networks in one form or another are just about everywhere. It's pretty difficult nowadays to find a place within reason, I guess, that you at least can't get some sort of signal to transmit something. And you have the layered security of GSM. I don't know how secure that is now, thanks to Chris's talk a couple hours ago, but it's at least there. So it's not like you're cracking web networks or anything like that. There is at least some sort of layered security, and the possibility of having a VPN tunnel between the meter and the utility station for that kind of direct point-to-point connectivity. Your disadvantages, you're really at the mercy of whoever you're contracting for the cell carriers. I mean, if a telco decides to change a new standard or change to a new set of form of infrastructure, and the meters are just incompatible with it for one reason or another, it's tough luck, I guess. Figure out a solution. I would assume that they would attempt to work with you, but the power companies are not going to probably stop cell networks from expanding or rolling out new technologies and things like that. And is it future proof? Well, I'm sure cell networks for now seem pretty solid, but how long really? We've been using basic utility meters for since power first started, and cell infrastructures are really have only come into play within the last 20, 30 years or so, and just a couple of things to think of, I guess.
Mm-hmm. So just for his third example, is kind of a couple other minor implementations, and I say minor just because you don't see them as often in the States. You may actually see power line. The idea is that your metering infrastructure is basically done over the same lines that transmit your power, and just because of the attenuation and the distance runs, you really see this in more small regions within countries in the EU, really in Japan, things like that. It's really, again, not really that common in North America, so it's a bit of a minor player. Broadband, it's just sort of interesting. There's been some specs out there for just sort of an open communication network, and it's very medium agnostic, and they use just a variety of existing transmission technologies. So in effect, you basically are putting open to using broadband, whether it's metropolitan Wi-Fi or basically 4G or whatnot. So the idea that you could basically create a sort of a set of standards, and again, pretty much TCP/IP based, that you could talk to, utilizing it. It's going to be very similar, in other words, to things like GPRS, and the idea that you can be flexible, I guess, with the leverage existing technologies. So next, you see how you communicate with the meter. Well, so what can you do inside your home once it goes inside the meter? So basically, the idea of home area networks and smart appliances. So it's going to home area network, and I'm sure a lot of you in the past have played with X10 and things like that. But so the idea about this is that you create something that's going to be a universal device interface that can communicate. You have a home controller, and it can communicate with your air conditioner, your fridge, down to your remote control, and maybe even your security system. So a variety of things. But obviously the challenges for that, if you want to have sensors on every last window, your doorbell, your remote, you have to have something that's a pretty small footprint, pretty low power, and that's kind of where Wi-Fi and Bluetooth kind of get knocked off, just because you're not going to have a remote control that is using 802.11 just because of the high power costs, and you're not using Bluetooth just because it is a fairly high power, as well as it has a pretty long wake-up time, so it's not really that good for instantaneous communication. Has to be secure on some level. I mean, you really don't want your neighbors playing with your stereo or, you know, disabling your security system when you're out of town. So, you know, you have to have some sort of security mechanism, and that's pretty much where X10 kind of drops off the map, as well as the fact that X10 has a very paltry transmission bandwidth for things like that. So, but still, despite that, we still need something that's low bandwidth. I mean, not, you know, pretty efficient. All you really need to do is send some sort of command, some sort of basic data set. So the thing that's been kind of the leader, or at least the winner in this so far, has been Zigbee. So it's actually, part of it is the IEEE 802.15.4, which basically specifies the physical and actually the data link layer. Zigbee kind of goes all the way up to the application profile, basically all the way up. And it's not TCP/IP, but it uses a very similar OSI model. So for practical and sensitive purposes, you can kind of intuit one over to the other. Again, it's a bit of a mesh star cluster topology. You can have devices relay from one to the other back to your sort of master controller, or your coordinator, I guess is the proper term. It's pretty low bandwidth, about 250 kilobits a second. You know, so not too much. It's actually it's sort of a, if you want to think about it, it's almost kind of like a bit of a peer-to-peer network of sorts. It's also another good kind of metaphor. And it was originally developed for industrial implementation, but the idea is it kind of carried over into home use, just because they thought they could find kind of advantages for it. It's really only, it's got a pretty short transmission range, about 100 feet. So you want things that'll stay inside the home, nothing that carries down the block, and on average, of course. So really, what some of the interaction that you'd want to be doing, let's say, let's say you take your car in for service, you get onboard diagnostics. Well, let's say your fridge compressor goes out, or your fridge compressor is failing. Your fridge notifies you and says, hey, I noticed my compressor is failing, you better dispatch someone. Saves you a little bit of headache and time and worry. You actually have, let's say a window says, okay, my window brake just broke, okay, trip the alarm, things like that. So you basically actually have different types of devices with different types of profiles, depending on what use. And again, this is actually secured by AES, and it's actually kind of, I guess, the trend in which AES is moving towards. For those of you who know a little bit about WPA2 with AES CCMP, you're turning a block cipher into a stream cipher. So they actually use something called EAX, which is sort of a less complicated version of CCM. The idea that you're basically chaining block to block without getting too much down the crypto path there. So, and after that, let's do a little bit of kind of the security and policy implications of all this, which is kind of the crux of everything, right? So basically what we want to know is this secure? And this is actually a damning question that used to be asked by a professor of mine, that he'd turn after showing a solution and basically say, okay, so is this secure? And you'd be absolutely paralyzed to actually answer this question, because you're afraid if you said yes, you'd have to explain why. And if you said no, you'd also have to explain why. In either way, if you were wrong, he'd absolutely just carve you up with the absolute correct answer. So to really answer this question, it does depend. And again, the best security in the world can be kind of cut apart by a poor implementation. So you have to ask yourself a few questions. So first of all, who are our attackers? Now, you may have someone who's just an enthusiast, kind of a thrill seeker, someone who's curious. I can't imagine there are too many of those people here. You have people, just vandals, people who kind of want to say, well, hey, if I can black out my neighbor, let's just mess with my neighbor. Let's, turn his laundry on, or, make his fridge burn out, or, just mess with people, vandals of sorts. And then, of course, probably the most interesting and probably the most dangerous type for this are basically, let's say, terrorism, espionage, people who actually are pretty well funded, pretty well intent on saying, if I can get control of this infrastructure, I can do some serious damage. I mean, let's say I can turn off the alarm system for a bank, I can black out an entire grid and cause havoc. It's a whole variety of things. So the second, it really only makes sense to use if you use all the features. So a lot of manufacturers say, well, gosh, we've got this, we've got AS, we introduce entropy, we do this, and then they say, oh, by the way, all these features are optional. And, well, yeah, if you strip out all the features, for example, of the 900 megahertz system, you're basically left with frequency hopping spread spectrum, which in itself, if you don't know the hop schedule, isn't it's okay as far as it is somewhat of a measure, except, well, let's say I go disassemble a meter, buy a meter on eBay, I get the hop schedule, and bam, it's just like you were, passing it across, in the clear. So, third, obviously, again, as Garrett mentioned, reliance on third-party security. You're putting yourself at the mercy of someone else's solution. And, a lot of utilities say, well, we don't really know a whole lot about that. We'll rely on AT&T to really kind of figure out what's going on. A lot of GPRS meter manufacturers will say, well, our network is private IP because, hey, that way no one can route to it. Well, so is every cell phone. So, again, some of these things that are touted as features are what we call feature fluff. It's just, these are things which are touted as features, but not really explained well, or just sort of a bunch of just crap thrown onto a piece of paper without actual context. And some of the other things, security through obscurity, it definitely, for example, they like to say, well, we use a proprietary frequency shift key and schedule. You won't actually, hey, they don't know it, it's not published, you won't be able to find it. Well, again, I grab myself a meter, I'll find it. Some of the proprietary command sets, well, how do people know how to send commands to meters? Our data set isn't published. Well, again, people with enough time will find a way. And probably most important of all is physical security. As anyone knows, really you can implement the best system known to mankind, but if I can physically access your devices, you're pretty much out of luck. So the idea, let's say I want to find out the frequency shift key, the frequency hopping schedule. So let's say, okay, I don't want to take apart my meter because then they might think it's me. Well, I don't really like my neighbor. I'm just going to steal his meter. They all talk on the same hop schedule. Well, bam, there I am. So again, physical security, you have to keep that into account. For example, in my particular complex, the meters are behind a locked door. So not too bad. It's at least an additional measure. So it's something to take into account. Again, the location, actually the spread nature of the network actually helps. It's sort of both a blessing and a curse. The idea that if I want to attack the network, I can basically go anywhere the network is. So, with buddy mode, I can pass commands off anywhere there's a meter. So it makes attacks on the network pretty hard to trace or diagnose. And again, kind of as a follow-up to physical security, you really have to be able to respond to incidents as they happen. So meter X is compromised, well, immediately revoke its key so it can't communicate for the network. And if you're anything like me, when you first read about a lot of the AES stuff, you said, well, why don't they just use PKI, something of that nature? Well, you got to take into account you're dealing with a system where every meter is inherently set up to be trusted, basically an explicit trust. So the idea is that if that key is compromised in any sort of way, you should be able to revoke it at the core and have the security of the system be retained.
Okay, so these are kind of the current. These are some marketing. I would call them marketing because they're not very technical, even though that was what some vendors were trying to portray them as. That I thought were a little entertaining. They told me not to, so I won't. This was a quote off of a promotional material for a meter. Our network is secure because they're telling you because we're purchasing licensed spec on the 900 megahertz spectrum, that inherently means just because we own that for the time being, that nobody could ever want to go do that, just because the FCC says that you're not allowed to. And well, obviously probably not so much, especially with folks here and everyone else that are just kind of wanting to play around with things. Transmissions cannot be duplicated using off-the-shelf equipment. With we have this outstanding device called a USRP, which is a software radio if you aren't familiar with it. And with that, and I can get a transceiver that broadcasts on 900, transmits and receives on 900 megahertz as well. With some, with a little bit of development or developer knowledge, I can customize the USRP in such a way that I should have no difficulties, at least trying to pick up traffic. And then once you pick it up from there, it's only a matter of time, depending on the security that's in place, on whether or not you can read it or do something with it in some capacity. Critical infrastructure. So that's for those that are unfamiliar, that's a designation by the Department of Homeland Security. They consider